Alexander Deutsch, and this is my video on the fundamental theorem of calculus part 1. So the fundamental theorem of calculus states, if f is continuous on the closed interval a to b, then the function g defined by the integral from a to x of f of t dt, when a is less than or equal to x and x is less than or equal to b, then the function g is continuous on the interval a to b and differentiable on the interval a to b. G prime of x will equal f of x. That to do with this would be to find the derivative given an integral. So the first step in solving such a problem is to check if the fundamental theorem of calculus is applicable. And since we know that 1 plus root 1 plus t squared is a continuous function from 0 to infinity, we can use we can use the fundamental theorem of calculus. So the second step would simply be to apply the theorem. And the idea is just taking the derivative of an antiderivative, which would just be the function. So the first thing to do is just replace the t's with the x's. So we'll write equals, and then we'll write root 1 plus x squared. And then we can simply write that f prime of x is equal to this by the fundamental theorem of calculus. Slightly more complicated, it asks you to find g prime of x when g of x is equal to the integral from x to 2 of sine t of t squared plus 1 of dt. So, remembering the integral rules, we can simply write that the integral g of x is equal to the negative integral from 2 to x of the same thing, t squared plus 1 dt. And then, now that we have this, we can simply use the steps learned in the first example. So we can simply write g prime of x is equal to sine of x squared, because we replace the t with the x's, plus 1 by the fundamental theorem of calculus. Complicated and requires slightly more steps. And the difference is because of this 2x here in the bounds of the integral. So the first step would be the same as in the other two examples, where you'd have to find if it was continuous or not. And since it is a polynomial, it is continuous and differentiable, so we can use the fundamental theorem of calculus. Next step would be to replace the t's with the x's. So we can simply write 2x cubed plus 2x squared plus 2, but then the difference is in where you have to use the chain rule in order to get the correct answer. And since the derivative of 2x is simply 2, we can use the chain rule to multiply this whole thing by 2, and then we can set that by the fundamental theorem of calculus equal to f prime of x. And that's the only difference with that one. Three rules, or all 4 rules, to complete this problem. So first off, we have to flip the function so that the x is on top. So then we find the derivative of the negative integral x fourth 3t cubed plus 3 dt. Secondly, we have to find if it's a continuous function and differentiable, and since it is in fact a polynomial, it is continuous and differentiable on all values, so we can then proceed to do the next step, which would be replacing the t's with the x's, so we can get x fourth to the third plus 3d. No, we don't need that. And then we have to use the chain rule, so the derivative of x to the fourth would simply be 4x cubed, so we have to multiply this whole thing in the parentheses by 4x cubed, and then we can simply set that equal to that. And then if you want to multiply it out even further, you can simply do that, but it's in this example I'm not going to And then you always need to write by the fundamental theorem of calculus. Otherwise it won't make sense in the context. Are the steps to solve. So the first step is to always check if the function that you're dealing with inside the integral, the integrand, is continuous and differentiable. If it is not, then you cannot do the problem. The second step would be to make sure the integral bound has x on top. If not, you have to flip using the negative integral rule. And the third step would be to replace the variable inside the integrand. In the 3-4 cases I did, it was always t, but it could be a different variable. So you have to replace that with the variable that's on the bound. So in the fourth step would then be to multiply the derivative of the bound with the variable, which is just a chain rule. In several of these cases it was just 1, so I didn't show it, but for other cases it was a different one. And fifth step would just be to write out the answer, and always to remember to write out by the fundamental theorem.